Looking at physics principle scenario number 3 here now. This is located on page 12 of the booklet that you got on Friday in class. This one says electrons are accelerated from rest by an electric potential difference of 300 volts. Right away, we know that when a charged particle speeds up, it's accelerating from whatever speed, in this case from rest. We know that's like a car going down a hill where we say EI equals EF. We'll do our little analysis of conservation of energy in a moment, but we know that's the physics principle that we're going to use. Once it leaves these parallel plates, this path of the electrons goes between these two parallel plates with a magnetic field as well. So there's an electric force and a magnetic force. The electric force is going to be downward. The electric force is going to be upwards because it's a negative particle attracted upwards towards the positively charged plate. But if you use the deflection rule for the magnetic force will be downwards. Thumb in the direction of the particle, fingers field, palm points downward. We have an electric force acting upward, a magnetic force acting downward, but I think it's pretty clear that the net force is downward on it. Bottom line is we have two problems here. Conservation of energy, EI equals EF, and then we have a couple forces that are unbalanced, and we're looking in that unbalanced force section to solve for the acceleration, the instantaneous acceleration as it enters these two charged parallel plates with the magnetic field. Let's do EI equals EF first. It says it starts at rest, so that's like a car at the top of the hill, has no kinetic energy, just potential, except in this case it would be QV potential, not MGH potential. At the bottom of the hill, it's got kinetic energy, 1 FmV squared. We're going to say the charge is 1.6 times 10 to the negative 19. The potential difference is 300 volts given to us. The mass of the electron is 9.11 times 10 to the minus 31. We're going to say solve for V. So we're going to get this number, take it over by dividing, and then square root that final speed as it leaves these two charged parallel plates is 102.65413 meters per second. Now, it leaves the parallel plates at that speed. It enters this electric/magnetic field combination, the green section, at that speed of 102.65413 meters per second. Let's analyze this green section now. Doesn't matter what we have here, charged particle, whatever. In the end, we have two forces acting. When we have two forces, we always do the same thing. F net is equal to the sum of the forces, Fe plus Fm. F net is also m times A. The electric force is QE. The magnetic force is QVB. Sub in some numbers here. We're given a mass here. It's an electron, 9.11 times 10 to the minus 31. Solving for A, okay, this is good because A is there and that's what we're looking for. Q of an electron is 1.6 times 10 to the minus 19. The electric field is 8.5 times 10 to the 5 newtons per coulomb. Plus QVB is once again 1.6 times 10 to the minus 19. We can't cancel that, by the way, because it doesn't appear in every term. The speed, 102.65413 times the magnetic field strength of 0.20 Tesla. Now we have to be careful here. This electric force is positive because it's upwards, but the magnetic force is negative because it's acting downwards. So what we want to do here now is solve for this positive number, solve for this, subtract it because it's positive electric force, negative magnetic force, get that number on the right-hand side, and then divide by 9.11. Do that, we get a value of negative 2.1 times 10 to the positive 17 meters per second squared. Now, they ask me for 10 to the negative CD. That's a typo. That should say 10 to the positive CD in that question. So our answer is negative 2.1 times 10 to the 17. We're going to express that as 2117. 2.1 times 10 to the 17. Bubble that in, 2117. Now we're looking for two physics principles. Again, I think in this one fairly clear. This one is conservation of energy, which is principle 5. And this one would be, this is accelerated motion, principle 1. Which one got us the answer? That would be accelerated motion, so we're going to list that one second. And then the other one that we used is principle 5. So we're going to bubble that in. We have 4 blocks, but we're going to use, we used principle 1 to get us the answer. Let's list that second. Principle 5 is the other one we used, and then those last 2 blocks are just going to remain blank.